Assalamualaikum girls. I am Shamsunisa from Royal Degree College Chemistry Department. Today we'll start Unit 4th General Chemistry. In that we'll see Chapter 1 Molecular Spectroscopy. In that we will study about interaction of electromagnetic radiation with molecules and types of molecular spectra. First of all, we'll see about interaction of electromagnetic radiation with molecules. So, spectroscopy is the study of the properties and the structure of molecules through the interaction of electromagnetic radiations with the molecules or compounds under study. This study deals with the different transitions that will be induced in the chemical species under examination when they interact with the electromagnetic radiations. So these interactions involve absorption or emission or scattering of electromagnetic radiations by the molecules. So electromagnetic radiation is a form of energy which is transmitted in the form of a wave with a constant velocity of 3 into 10 to the power 8 meters per second. The wave consists of oscillating electrical and magnetical fields. Here you can see the figure. Electromagnetic radiation, how it is propagating, direction of propagation also mentioned here. And here, this particular electromagnetic wave, it consists of what? Oscillating electrical and magnetical fields. Both these fields, they are mutually perpendicular to each other and is also perpendicular to the direction of propagation of the wave in space. But in spectroscopy, we are concerned with electrical component only. So the electromagnetic radiation wave is generally divided into different regions on the basis of energy of the radiation or other properties of waves such as wavelength and frequency. So electromagnetic radiation of different regions is absorbed by the molecules if only certain conditions are satisfied. Then the most important of these conditions is the chemical nature of the molecule. Here we can see the example. Ultraviolet radiation is absorbed by a molecule if the molecule contains mobile electrons. Those are nothing but pi or lone pair of electrons, that is n electrons. Visible radiation is absorbed by almost all types of the molecules containing pi electrons and lone pair of electrons. Then infrared radiation is absorbed by a molecule if only the molecule is a dipole or at least acquire dipole character on excitation of the molecule. Microwave radiation is absorbed by permanent dipoles or dipolar molecules only. These are the conditions. So for the purpose of chemical spectroscopy, the total energy of a molecule is subdivided into 4 different types based on the different modes of molecular motions. The first one is electronic energy. So this is the energy associated with electronic transitions from one orbit to the other. That is from N1 to N2. Second type of energy is translational energy. That is displacement of molecule in space. And third type of energy is vibrational energy. Here the vibrations of atoms bound by bond. Fourth type of energy is rotational energy. That is rotation along the axes, that is x-axis, y-axis and z-axis. Since translational motion of a molecule is not important in molecular spectroscopy, so the total energy of a molecule relates to the energies involved in the electronic transitions, vibrational level changes and rotational level changes in molecules. So here you can see the formula to calculate the total energy. Total energy, it is equal to electronic energy plus vibration energy plus rotation energy. If we are adding these three types of energy, we get the total energy. So the values of translational energy, rotational energy and vibrational energy components in a mole at T is. So here average translational energy is equal to 3 by 2 R. Here the directions are three directions. And rotational energy is equal to 3 by 2 R. Here also 3 directions. And the vibrational it is equal to R. Now we'll study about types of molecular spectra. Absorption of electromagnetic radiation, those are nothing but photons, by a molecule may lead to change in internal energy, that is electronic, vibrational and rotational of the molecule, or even cause transitions between the different spin orientations of atomic nuclei of the atoms in a molecule when it is placed in a magnetic field. So hence it is possible to effect a specific change in a molecular energy using electromagnetic radiation of appropriate frequency or wavelength or wave number. In some cases, depending on the magnitude of energy of incident radiation or absorbed radiation, all the changes, what are those changes? That is electronic, vibrational and rotational changes takes place. The magnitude of these energies are different. That is electronic energy, it is showing more magnitude compared to that of vibrational energy. Vibrational energy will show more magnitude compared to that of rotational energy. So rotational energy is showing the least energy, that is we can say least magnitude rotational energy will show as compared to electronic energy. Depending on the quantum of energy absorbed by a molecule, that is depending on the nature or type of radiation. What are the types of radiations? Ultraviolet, visible, infrared, microwaves. Characteristic changes takes place in the molecule. These are electronic changes. Another type of changes, vibrational changes and rotational changes. Absorption of electromagnetic radiation may cause transitions between different spin orientations of nuclei placed in a magnetic field. Now, based on this, molecular spectroscopy is classified into 6 types. How many types? Molecular spectroscopy classified into 6 types. What are they? First one is ultraviolet spectroscopy or visible spectroscopy. Infrared spectroscopy. Third one is pure rotational or microwave spectroscopy. Fourth one is nuclear magnetic resonance spectroscopy. Abbreviation is NMR. And next is electron spin resonance spectroscopy. ESR is the abbreviation. And the last one, sixth type of molecular spectroscopy is mass spectroscopy. Now we'll see about ultraviolet and visible spectroscopy. What is this? This deals with electron transitions that occurs between the different electron energy levels of a molecule due to absorption of ultraviolet radiation or visible radiation. In the study of molecules in the gaseous state, vibrational and rotational changes to accompany the electronic energy level changes. But in the liquid state, these will be absent. Only electronic changes takes place. What are the changes absent in the liquid state? Vibrational change is not there. Rotational change is not present. Only the electronic changes takes place in the liquid state. Here you can see the range, wave number of visible light. It ranges from 13,000 to 26,000 per centimeter. Near ultraviolet, wave number is 26,000 to 50,000 per centimeter. And the wave number in the vacuum ultraviolet is, it ranges from 50,000 to 10 to the power 6 per centimeter. Now we'll see about the second type of molecular spectroscopy, that is the IR spectroscopy. Absorption of infrared radiation results in the appearance of the infrared spectra. The changes that occurs are in vibrational level as well as rotational level of energy in these spectra. The wave number range of infrared radiation used is 4000 to 667 per centimeter. Dipole and oscillatory dipoles exhibit these spectra. Next, the third type we will see, that is the pure rotational or microwave spectroscopy. This spectroscopy is concerned with the changes in rotational energy levels only. Dipole or polar molecules exhibit these spectra. The wave number of the radiation involved is in the range 10 to 0.1 per centimeter. Next, the fourth type of spectroscopy is nuclear magnetic resonance spectroscopy, NMR. So this spectroscopy is concerned with the study of interaction of energy with spin active nuclei of atoms. Here I value it is equal to 1/2 or 3/2 or 5/2 and so on. These poses permanent nuclear magnetic moments and quantized nuclear spin states. This spectroscopy deals with the transitions between the different states of nuclear spin orientation of the nuclei placed in an external magnetic field. So here the number of spin states is equal to 2I plus 1. Next type of spectroscopy, that is the molecular spectroscopy, we'll see that is nothing but electron spin resonance spectroscopy, ESR. This is used to study atoms, ions, radicals and molecules containing odd number of electrons. These display characteristic magnetic properties arising from the spin of unpaired electrons when under the influence of an external magnetic field. This magnetic moment of spin odd electron may occur either of the two spin orientations. These are either aligned or opposed to the external magnetic field in which the nuclei are placed, corresponding to the two energy levels for the electron spin. So ESR is similar to NMR spectra of protons. Under the conditions of resonance, there will be transfer of electron magnetic moment of the spinning electrons from lower energy state to the higher energy state. Then the last type of molecular spectroscopy is mass spectroscopy or mass spectrometry, we can say. This is based on the principle that molecule in the gaseous state or vapor state are bombarded with the electron beam. How much? 70 electron volts. They are converted into parent and daughter positive ions. So parents are nothing but initial formula and the daughter positive ions are nothing but fragments. These positive ions, which are considered to be as fragments, are sorted out according to their mass number with the help of applied joint magnetic and electric fields. The sequential arrangement of molecular ion fragments as per their mass number is called mass spectrum. Thank you for listening my lecture.